So we're going to go over your Unit 1 equations that we talked about forever ago. And I'm just going to do some of each type here to kind of give you a refresher. First thing we did talk about, one of the first things we talked about in Unit 1 was our absolute value equations. With your absolute value equations, one thing you have to do, or what you have to do at first really, is just isolate that absolute value. So here I'm going to add 7 to both sides. And then I'm going to divide by that negative 7. So you get the absolute value of 5n plus 1 equals 1. With these, this is where we did have to split the problem into two distinct issues, because we have to consider the multiple things that this 5n plus 1 could equal in order for its absolute value to be 1. And there's two things that could equal. First off, 5n plus 1, if it equals 1, then the absolute value of that is 1. And second off, 5n plus 1 could equal negative 1, because then that means this in here would equal negative 1. And when you absolute value negative 1, you get positive 1. And so now we're just going to solve. You're going to solve each of them separately. So on this first one, I get n equals 0. On this second one, I get n equals negative 2 over 5, or negative 0.4. Done. One of the other things we talked about was inequalities, and so we're going to practice being able to both solve this and graph this here. The first thing that I would take care of here is this distributing. Some people at this point accidentally try to FOIL this out, so please make sure you're just distributing that negative 4 through. There is not another parentheses, so that negative a doesn't matter with the parentheses. So it's going to be negative 12a and then minus 24. Then I'm going to combine some like terms. So let's see, I have negative 128 is less than or equal to negative 13a minus 24. And if I add that 24 over, I'm going to get negative 104. It's less than or equal to negative 13a. And then 104 divided by the 13 gives me 8. And the a, because I divided by a negative, it is very important that you flip your inequality here. And remember, anytime you divide both sides by a negative, so here I divided by negative 13, that inequality will flip. The other thing we do like with with inequalities is for our variable to be on the left side, or at least for when we graph it. So if I wanted to flip this, I can put my a on the left and my 8 on the right. I have to make sure that the inequality is still open towards the a. And so this really says a is greater than or equal to 8. When I go to graph this, the equal to tells me there's going to be a closed circle on the 8. A is greater than, so everything to the right. That would be my final answer. What we also got into is what was called compound inequalities. When it's written like this, it tells you there's really two inequalities in your problem. You know that negative 7 is less than 2m minus 5. You also know that 2m minus 5 is less than 5, so that you have both of those going on. If they're written together, you can take advantage of it and work a little smarter and not harder by remembering that, hey, if I'm isolating this m, I would add 5. So I'm just going to add 5 in all 3 spots. And then I would divide by 2. So I'm going to divide by 2 in all 3 spots. And it tells me negative 1 is less than or equal to m is less than 5. You don't flip your inequality here because I didn't divide by a negative. This 2 is positive. So this would be my solution. When I go to graph it, I need a closed circle on the 1, or on the negative 1. I need an open circle on the 5. And this is saying to me everything between negative 1 and 5. So I'm going to shade in this interior region. Once we talked about those, we also discussed absolute value inequalities. And these got a little bit trickier, and so we'll talk these through. Just like with your absolute value equations, you do need to start by isolating your absolute value. So I'm going to add 4 and then divide by that 4, and you get negative 5 plus 4n. Let's see, that's 84 divided by 4 is greater than or equal to 21. And then we talked about how you still have to split it because it's an absolute value. The first time when you split it, you just drop those absolute value bars. The second time when you split it, you have to both flip the inequality and change the sign on the absolute values. So you flip your inequality and change the sign. You also have to look at what your inequality was to decide whether this is an and or an or. Since it is greater than, this will be an or equation. If it was less than at this point, it would be an and equation. And so now I'm going to go ahead and solve these. When I add 5, you get 4n is greater than or equal to 26. So n is greater than or equal to 7.5, if I did my math correctly. Yep. Oh, 6.5. There we go. So this is one of my two inequalities. Or this other one has to be true. When I add 5 over, I'm going to get 4n is less than or equal to negative 16. And then when I divide it, n is less than or equal to negative 4. It's important that this is an or because ors don't require overlap. Anything you shade will be an answer. So when I go to do it, 6.5 is going to be filled in, and it is greater than that. So that would be my shaded region. And then from negative 4, and shade to the left because it is less than. And again, there's no overlap, so just both of those regions are my answer. We're going to try this one also. If you are welcome, as always, to pause this and see how far you can get, and then just play it and listen to the explanation if you're ready, when you're ready. Again, we want to isolate our absolute value, so we're going to add 1. And then divide by that 2. And you should get 3n plus 8 absolute value is less than or equal to negative 7. Then I'm going to split it. So 3n plus 8 is less than or equal to negative 7. 3n plus 8 is greater than or equal to positive 7. And since this is less than, it tells me it is an and equation. So again, greater than at this point would be an or, less than at this point is an and. And then I'm going to just solve both of these. So I would subtract 8. 3n is less than or equal to negative 15. And so n is less than or equal to negative 5. Doing the other one, 3n is greater than or equal to negative 1. So n is greater than or equal to negative 1/3. This is an and, which requires overlap for there to be an answer. So when I go to graph them, n is less than or equal to negative 5. It'll be closed circle and shade to the left. N is greater than or equal to negative 1/3. When I shade these, there is no overlap, which means this is no solution. Other thing we're going to talk about, and I'm going to talk about this in each days of notes, is how we found our inverses of functions. And we did this a couple different ways, and so I'm going to remind you of that as we go throughout. One of the things we did back in the first chapter was I would give you two equations and ask you to state if they are inverses or not. And this is where we really specifically had two different methods, and so I'm going to show you both of them. Your first method that you can choose is to do f of g of x and make sure that that just equals x. Okay, you can also do g of f of x, both will work. If you think back, what that really tells you to do is you're plugging one function into the other. So for example, if I wanted to do method 1 with this one, I could plug g in for x in the other equation. What that would mean in this case is I'm doing f of g because I'm plugging g into f, and I'm just going to replace x with the other equation. This one's kind of ugly because it has a lot of fractions, but you'll see pretty quickly that it kind of evens out. When I do this, if I multiply negative 6/5 times negative 5/6, I just get 1. So it's 1x. When I do negative 6/5 times 5/3, and again, you can use your calculator, you end up getting negative 2. When I combine this together, I get just x. So this would tell me that, yes, they are inverses. But again, that's not the only method you could choose. What method 2 was to flip your variables in one of the equation and solve and see what you get for your other one. So say I wanted to take equation f, it wouldn't matter. I could take it and switch my f and my x value. This is the way that most people opted to do it back in the chapter. And now I want to solve for f. So say I would subtract 2. To get rid of this 5 that's in the denominator, I would multiply everything by 5, which means it's going to give me 5x minus 10 equals negative 6f. And then I'm going to divide everything by negative 6. The f is alone, so now that's my inverse, if you remember that notation. And it gives me negative 5/6x plus 10 over 6 simplifies to give me 5 over 3. If you do it this way, what you are checking is, does the equation you found match the other equation that you were given? In this case, it does, which is what leads me to also say that yes, they are inverses. So again, you do not have to do this both ways. You could do it either method 1 or method 2. Either gives me the same answer. But that's how you would verify if two equations are inverses of each other. What we talked about back in Unit 1, just as a refresher, is inverses really meant that your x's and your y's were all flip-flopped, which is why this second method does in fact work. The other thing we did is I sometimes just gave you one equation and told you to find the inverse, and so that's what we're going to practice here. To do this, you are really just doing method 2, which is also why some people opted to do that during Unit 1. So we'll just get you some practice doing this. For this first one, again, I would flip my variables, so x equals negative 8h minus 4, and now I need to solve for h. So I'm going to add 4, and then I would divide by negative 8 across the board. So my inverse of h would be negative 1/8 x minus 4 over 8 is really a half. This would be my answer. To try this next one, again, I would flip my variables. I would personally get rid of this 2 first since it's under everything. So I would multiply both sides by 2. So you get 2x equals, those cancel, 8 minus f. You would subtract that 8 over. And then there's this negative still here, so I need to divide everything by negative 1. So my inverse of f would be negative 2x plus